Hello everyone, I am Dr. Sirajul Faisi. I welcome you in my YouTube channel. Today in this video I am going to talk about thermal analysis technique, and I hope this video will be helpful to you. So, you know what is the thermal analysis technique? So a group of techniques in which a physical property is measured as a function of temperature. A group of techniques in which a physical property is measured as a function of temperature. The sample is subjected to predefined heating or cooling programs. Now, types of thermal analysis. First, TG, thermogravimetry. T for thermo and G for gravimetry. So, thermogravimetric analysis related to weight. DTA, differential thermal analysis, temperature. And DSC, differential scanning calorimetry, temperature. Now, what is the meaning of this analysis? Laboratory studies clays and minerals by an examination of temperature time curves. Later, Robert Austin improved technique by introducing thermocouples. So, what is the definitions? DTA is a technique in which the temperature between sample and thermally inert reference substance is continuously recorded as a function of temperature per time. Now, in DTA, both test sample and an inert reference material, alumina, controlled heating or cooling programming. In zero temperature difference, sample and reference materials between sample does not undergo any chemical or physical change. If any reaction takes place, temperature difference delta will occur between sample and reference materials. Now, this is the temperature versus delta T changing difference graphs. You see up one exo, down one indo, and displacement for estimations and heat capacity change. The differential thermal analysis is a technique in which the temperature of the substance undergo investigation is compared with the temperature of a thermally inert material. Now, what is differential thermal analysis? Sample holder, sample and reference cells, sensor, chromel, alumel and thermocouple of platinum, rhodium, one for the sample and one for the reference, joined to differential temperature control. Furnace, alumina block containing sample and reference cell. Temperature controller, control for the temperature program and furnace atmosphere and recording system. Now, DTA instrument, you see the pictorial picture. What is advantage? Instruments can be used at very high temperature. Instruments are highly sensitive. Flexibility in crucible volume and form. Characteristics, transitions or reaction temperature can be accurately determined. What is the disadvantage? Uncertainty of heats of fusion, transitions or reaction estimations is 20 to 50%. Now, what is the applications of differential thermal analysis? Qualitative and quantitative identification of minerals, detections of any minerals in a sample, polymeric materials. DTA useful for the characterizations of polymeric material in the light of the identification of physical, thermochemical, thermomechanical and thermoelastic changes or transitions. Measurement of the mass fractions of the crystalline material in semi-crystalline polymers. Analysis of biological material. DTA curves are used to date bone remains or to study archaeological materials. Now friends, differential scanning calorimeter, we call it DSC. This technique is developed by E.S. Warston and J. Neil in 1962. Introduced commercially at the Pittsburgh Conference on Analytical Chemistry and Applied Spectroscopy. First adiabatic differential scanning calorimeter that could be used in biochemistry was developed by Prevel in 1964. What is the principle? In DSC, the heat flow is measured and plotted against temperature of furnace or time to get a thermogram. This is the basis of differential scanning calorimeter. The deviation observed above the base zero line is called exothermic and transition and below is called endothermic transitions. The area under the peak is directly proportional to the heat evolved or absorbed by the reaction, and the height of the curve is directly proportional to the rate of reaction. Now this is the pictorial diagram of DSC curve. Heat flux DSC. Sample and reference are connected by a low resistance heat flow path. Aluminum or platinum pans placed on constant in disk. Sensor Chromel's Constantin area thermocouple differential heat flow and sample temperature. Furnace one block for both sample and references. Temperature controller. The temperature difference between the sample and reference is converted to the differential thermal power dQ dt, which is supplied to the heater to maintain the temperature of the sample and reference at the program's value. Now friends, you see the pictorial diagram of heat flux DSC. Dynamic sample chamber, reference pan, sample pan, lead, thermocouple junctions, heating block, chrome disc, gas purge inlet, chrome disc, alumina wire and chromel wire, like that. Now sample holder, you can see here aluminum or platinum pans, platinum resistance thermocouples, separate sensors and heaters for sample and reference, furnace separate blocks for sample and reference cells, temperature controller differential thermal power is supplied to the heater to maintain the temperature of the sample and reference at the program's value. Now you can see the application of DSC. Protein stability and folding, liquid biopharmaceutical formulations, process development, protein engineering, rank order binding, antibody domain studies, characterization of membrane lipids structure, nucleic acid and micellar system, assessment of the effect of a structural change on a molecular stability, measurement of ultralight molecular interactions, assessment of biocompatibility during manufacturing. Now application of DSC. Polymers, composition of polymers is determined, melting point and large transitions temperature can be determined. This can show the polymer's degradation by lowering the melting points. Molecular weight, low grade, low melting point can be determined. Percentage crystallinity and thermal degradations impurities. So friends, liquid crystal oxidative stability and optimum storage condition. Drug analysis, widely used in pharmaceutical industries, defining processing parameters, and polymer industries, curing process. General chemical analysis, freezing point depression can be used as a purity analysis tools and functional analysis binding studies. So friends, of DSC binding study sites, these are the reference. So friends, hope this video will be helpful to you. If you like this video, then please subscribe my channel, and thanks for watching.